Hey everyone, welcome back to my channel. How's it going? In today's video, we're going to continue solving practical challenges, which I hope you will find helpful and hopefully interesting. Alright, so this is our first problem that we need to solve here. Basically, we have two fair-sided dices and we're rolling them. And we have two events, event A, when our sum is even, and the event B, when our die is 6. Only one die is 6. So what we need to do here is to find the probability of event A and the probability of event B. So let's just try to find them. The probability of event A is obviously when the sum is even. Let's just try to list out all cases when the outcome is even. Obviously, the first case is when we have two odd numbers, and the second scenario is when we have two even numbers. In case if we have one even number and one odd number, the outcome, their sum will be obviously odd. So we're not considering them. Right, so we have two odd numbers and two even numbers. In case we have two odd numbers, we may end up having 1 and 1, 1 and 3, and 1 and 5. Or the other way, 3 plus 1, 3 plus 2, and 5 plus 1, 5 plus 3, and 5 plus 5. So we have 9 possible outcomes here. And the same goes for even numbers. 9 possible outcomes here, and 9 possible outcomes here. So the total number of possible outcomes here is obviously 36, because if you take a look carefully, the first dice may end up with a number from 1 until a 6 in the second die, and so does the second die from 1 until 6, which will give us 6 times 6, 36 possible outcomes. So 9 plus 9, the outcomes which satisfy the event A, over 36, which will give us 18 over 36, which will result in 1 over 2. So the probability of event A is 1 over 2. The probability of event B is basically when our die is 6. How to find that one? So event B happens when one of our dice end up with having 6. For the second die, it can be any number from 1 to 6. Obviously, we have 6 possible outcomes here, plus 6 other possible outcomes. When the first die is not 6 anymore, it can be an arbitrary number, and the second one should be 6. So for example, we have 1 and 6, 2 and 6, 3 and 6, and so on. And for the second scenario, we have 6 and 1, 6 and 2, 6 and 3, until 6 and 6, and 6 and 6 here. So there is an overlap. So we need to exclude one possible outcome from our counting. So we have 6 plus 6 minus 1, because this is the overlap when we don't have to double count it. We need to exclude that from counting and divide by 36 total possible outcomes. So that will give us 11 over 36 is the probability of the event B. Now, the second thing this problem asks us is basically find the probability of intersection of those events, the intersection and the union of those events. So basically, the probability of A intersection B and the probability of A union B. How to find those ones? First, we have to define what the intersection of those events means. If the first event happens, that means the sum of the outcomes is even. But if the event B happens at the same time, that means one of the dice is also 6. So in case when one of our dice comes up with a 6, that means the second number should be even as well. For example, 6 and 2, 4 and 6, 6 and 6. Because if it was an odd number, 1 and 6, the sum of those numbers wouldn't be even. That would be 7 and so on. That's why we need the first number is even. So as a result, we have only 3 possible outcomes when the second dice is 6, and 3 possible outcomes when the first dice is 6. So the probability of A intersection B is 3 plus 3 minus 1, because we again have an overlap, like 2 and 6, 4 and 6, 6 and 6, and 6 and 2, 6 and 4, and 6 and 6, the second overlap. So we need to subtract this overlap from our possible outcomes here and divide by 36, which will give us 5 over 36 is the probability of the event A and B happening simultaneously. So one can notice that those events are actually not independent, because if you try to calculate the probability of A, as we figured out, it is 1 over 2, and the probability of event B, which is 11 over 36, you can notice the product of those probabilities, P of A and P of B, is actually 1 over 72, which is not 5 over 36, which is not the probability of intersection of those, which essentially means that these events are not independent. And now let's try to find the probability of union of those events. So if you have the event A and event B, and you need to find if either of those events happened, at least one of them happened, in other words. So you just need to calculate the probability of event A plus the probability of event B. Those events are actually not mutually exclusive. They can happen at the same time. They can happen simultaneously. So we need to subtract their intersection. And let's now try to find out what it would be. It would be P of A 1 over 2 plus 11 over 36 minus their intersection, the probability of their intersection, which is 5 over 36. That will give us 1 over 2 plus 6 over 36. Let's try to do some arithmetic here. It's going to give us 18 over 36 plus 6 over 36 over 36, 24 over 36. And now if we try to reduce this fraction, we're going to have, obviously, if we try to divide that by 4, 6, and 9, and by 3, 2, and 3, should give us 2 over 3. So that's basically the probability of their union. So that was pretty simple. Now let's try to tackle the second problem. The second problem states that we have a deck of 52 playing cards, and we have 3 possible outcomes. The outcome C, which states that we have a red card, which can be heart or obviously the diamond. So we have 26 possible outcomes here. The face cards is like a jack, queen, or king, which is in 4 suits will give us 4 times 3, 12 possible outcomes. And the event E is basically having the heart, which is 13 possible outcomes. And now, the first thing that our problem asks us to do is to find the probability of the intersection of event C and event D, probability of the union of those events. So for the first case, we need to find the probability of C or D. Now let's take a look carefully if those events are mutually exclusive or not. If you try to draw a red card, you may end up having the face card and the other way around. So that means those events are not mutually exclusive. It is possible to have a red face. So we need to figure out how to find them then. So the probability for those union would be the sum of probabilities based on our formula minus the probability of their intersection. So all we have to do is to find our intersection, and we automatically end up with an answer for this case. So let's try to find the intersection of those events. Well, how many possible outcomes we can have in this case? That should be red face. Since we have a symmetric number of faces in each suit, we can only have 6 possible red faces, 3 diamonds and 3 hearts. That means we're going to end up with 6 possible outcomes over 52 total outcomes. 52 total outcomes, which will give us 3 over 26. Now, if we need to find the union of those events, we just need to find the probability for C plus the probability for D minus 3 over 26. Now, let's try to find the C. So it's pretty much simple. It's over 26 over 52 plus the probability of D, which is 12 over 52 minus 3. To be more accurate, 6 over 52. That will give us 32 over 52, which is 16 over 26, which is 8 over 13. Give us 8 over 13. That should be our probability. The second thing that our problem asks us is basically to find the probability of event D given event E, which indirectly points to the fact that they are actually dependent on each other. So now let's try to figure this out. Given event E, which means we are going to end up having the heart, what would be the probability that this heart is actually a face card? There are 2 ways to find this. The first way is just list out all possible outcomes. Well, in that case, since we have only 13 hearts, and amongst those 13 hearts, 3 possible face cards, which is 3 over 13, that would be the probability of our event. And the second way of calculating that is actually to use our formula, which is the probability of their intersection over the probability of one of those events. The intersection of them is basically that we have the face heart, the probability of having the face heart is 3 over 52 times 1 over probability of event E, that is the heart, which is 13 over 52. Now, if you try to find that, would be 52 times 52 over 13, which will give us 3 over 13. So there are two common ways to compute this probability. Now let's try to solve the C. Event D and event not C. This is negation of the event, the complementary of the set C. What it asks us to do is basically find the not red card, the black card, which is at the same time a face, black and face card. Which kind of cards are here? Well, essentially we have 6 possible outcomes. We have clubs and we have spades. We have 3 face possible clubs and 3 face possible spades, which will give us the probability 6 over 52, which is essentially 3 over 26. And that's it. That's how we can find the probability for this situation. And that wraps things up for today's video. I hope you really found this video helpful and learned something new. And if you did, consider subscribing to this channel. And we also have our own Discord communities. So feel free to follow the links down below in the comment section and join our community. And thank you for watching. See you next time. Bye.